Welcome back, smart mathematicians. Let's do the last part of question 12. A teacher is 5 poetry books, 4 different dramas, and 3 different novels. She must arrange these 12 books from left to right on the shelf. Calculate the probability that a poetry book is placed in the first position. So it means this one is fixed. We must have a poetry book in the first position. 3 novels are placed next to each other, and the drama is placed in the last position. So this one again is fixed. So we want probability. Remember, we have the total number of the possible ways, which is 12 factorial, isn't it? That is our denominator now. But now, how many ways can these books be arranged in this way? Where we have a novel in the first place, a drama in the last position, and then the novels placed next to each other. Okay, so how many ways can we have these arrangements? Let's discuss this. So the first position and the last positions are easy because they are fixed. So let's say this is the last position, first position, and then this one is the last position. Okay, how many choices do we have for the first position? We're saying the first position is what? 3 novels. So we have the first position should be what? Calculate the probability that a poetry book is placed in the first position. So poetry book. So we have 5. So first position is 5. And then last position, drama is placed in the last position. How many dramas do we have? We have 4 dramas. So we have 4 choices. So the first position is 5 choices. The last position, 4 choices. Remember, okay? So it means we're going to have one book here, which is a poetry book, and then we're going to have one book here, which is what? Which is a drama. So how many books are we left with now? We're left with 10 books, okay, to arrange. Now they're saying the novels must be next to each other. So these 3 books must be next to each other. So we have a novel, a novel, and a novel. See that? So these novels must be next to each other, meaning that we have 3 factorial arrangements here for these novels. 3 factorial arrangements. And then we treat this one as a unit. This whole box here for novels, we treat it as a unit. Okay, so how many books now have we covered now? One book being the poetry book in the first position, one book being a drama there in the last position, and then the novels being arranged what? Next to each other here. So we have a total of what? Of 5 books now. Okay, and then these 7 other books can be arranged anyhow. So we have 7 other books. Let me just put them here. 1, 2, 3, 4, 5, 6, 7 books. They can be arranged anyhow. So we have 1, 2, 3, 4, 5, 6, 7. But remember, this unit here is not what? Is not fixed at this position. It can also be arranged in different ways with these other books. So it means from here up to there, we have what? How many arrangements? 8 factorial arrangements. We have 1, 2, 3, 4, 5, 6, 7, 8 things. Because remember, we're treating this as what? As a unit. So now, how many different ways can we have this arrangement where we have the poetry book being the first book, the drama book being the last book, and then novels being arranged next to each other? It means we have to say 5 times 3 factorial times 8 factorial times 4. Okay, but remember, we're looking for probability. So it's going to be probability start with poetry and then end with drama and all novels together. Okay, Right, what is the probability there? We're saying it's going to be 5 times 3 factorial times 8 factorial times 4. All this divided by 12 factorial, remember, okay? Right, and then becomes 1 over 99. That's how you find the probability, okay? Right, we'll meet when we're doing our other examination packs. Thank you.